Okay, let's start with question number 51, which is integer type. For a point P in the plane, let D1P and D2P be the distances of the point P from the lines x minus y equals 0 and x plus y equals 0 respectively. The area of the region R consisting of all points P lying in the first quadrant of the plane and satisfying the condition D1 plus D2 is between 2 and 4 is. Fine. So we can start by tracing first two lines and a point in that plane. Line x minus y equals 0 and x plus y equals 0. Correct? We have a point which is such that D1 and D2 are the distances of that point from these two lines. Fine, we can take any point, say here, such that this sum is between 2 and 4. Correct? So we can simply find the distance like mod of x minus y by root 2 plus mod of x plus y by root 2 is between 2 and 4. We observe two cases because we are dealing in the first quadrant only. One, x is greater than y, other x is less than y. If x is greater than y, it will give me x minus y upon root 2 plus x plus y upon root 2 between 2 to 4. Fine, y will be cancelled out, so we obtain x is between root 2 to 2 root 2. Similarly, when we take x is less than y, we will get y is between root 2 and 2 root 2. We can trace these lines as in the first quadrant. So this is the required area in the given interval. Correct? So we simply require the area as the area of the bigger square minus area of the smaller square. The area of the bigger square becomes 2 root 2 square, that is 8, of the smaller square, that is root 2 square, means 2. So required area equals 6. So the required answer is 6. Clear? Let's move to the next question. Okay, let's go for question number 52. Let ABC be three non-coplanar unit vectors such that the angle between every pair is pi by 3. If A cross B plus B cross C equals PA vector plus QB vector plus RC vector, where PQR are scalars, then the value of P square plus 2Q square plus R square divided by Q square is. Fine. So another question based on vectors. ABC are unit vectors such that angle between each pair is pi by 3, means A dot B equals B dot C equals C dot A equals half. Now we can find the scalar triple product ABC square, which is given as A dot A dot B, A dot C, B dot A, B dot B, B dot C, C dot A, C dot B, C dot C. It will become 1 half 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 1 half 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 1. Simplify it, it gives me half. So scalar triple product ABC equals plus minus 1 by root 2. Correct? Another equation given to me, A cross B plus B cross C is PA plus QB plus RC. If I take dot product with this equation with A vector, B vector, C vector respectively, I obtain equations like, when I take with A, it becomes A dot A cross B plus B cross C equals A dot PA plus QB plus RC. Correct? Now, A dot A cross B is 0. This is scalar triple product ABC. So we obtain box ABC equals P A dot A, that is 1, Q by 2, R by 2. So we obtain one equation. This scalar triple product ABC can be written plus minus 1 by root 2. So we get 2P plus Q plus R equals plus minus root 2. Correct? Similarly, when we take dot product with B, this is 0, this is 0. We give P by 2 plus Q plus R by 2 equals 0. When we take dot product with C, it is dot A cross B dot C means a scalar triple product. This becomes 0. So we obtain plus minus 1 by root 2, or on simplification it will become simply root 2. On the other hand, P by 2 plus Q by 2 plus R, we have taken LCM, it gives me P plus Q plus 2R. We can solve the three equations to get the result like P equals R equals minus Q. Further simplifying, we get the values for P, Q and R as 1 by root 2, 1 by root 2, minus 1 by root 2, or minus 1 by root 2, minus 1 by root 2, 1 by root 2. Correct? Positive, or when we take the negative sign, P equals Q equals minus 1 by root 2 while R becomes plus 1 by root 2. Now substitute these values for P, Q, R in this expression. It gives me 1 by 2 plus 1 plus 1 by 2 divided by 1 by 2 or 4. So result for this question is 4. Let's move to the next one.